Hey, what's up? It's Triggy. Animals have had millions of years to figure out how to take turns, and they still haven't solved it. And why? Well, birds simply aren't going to spend all day designing contraptions to solve their problems, but I will. There's a 3D printer in my workspace and a bunch of people who want to use it, which means I often have to wait or babysit the machine to make sure that I'm next. Now, there are easy ways to handle this with a spreadsheet or sticky notes, but I think we can do better. And I want to add a constraint to this build. I want it to be strictly mechanical. So I built a machine, complete with chains, sprockets, bearings, and a crank to keep track of whose turn it is purely mechanically. The complete plans aren't going to make a ton of sense right now. Let's make a few parts first, then come right back to this. First thing we'll need is a chain and sprocket. This will work just like the gears on a bike, or like the treads of a tank. I'll model and print these links, and connect them with some M3 bolts. This gives us some very satisfying behavior. 2 sprockets will get a bearing press fit into place, and 2 will get an M8 nut. Okay, let's see what we're going to do with these. The plan is to set the sprockets onto 2 M8 threaded rods like so. The chain will be looped around so that when the top rod spins, so does the chain. This will be duplicated onto both sides of the device, which means a plaque can be placed between them, which we will use to keep track of whose turn it is. This will become clear. Let's get this thing built first. Instead of 3D printing the housing, I went back to basics and used MDF, basically wood, but worse. Now I'll give it the flesh-colored landlord special. This is going to need bearings, so I'll first pop those bearings into the holders. Then those fit into the corresponding pieces of the housing. Since this is a press fit, I need a little force. This is typically no problem, but the geometry I constructed here is pathologically inconvenient. In hindsight, this should of course have been done before assembling the housing, but I eventually get the job done. Okay, now with that out of the way, we can get to the good stuff. These M8 threaded rods hold our sprockets and slot right into place. This is the first big test of the build. Do the sprockets interface with the chain, and is the distance exactly right? I left 2 millimeters of slack in the design, and I'm glad I did, as closing this chain was just doable. And this motion looks excellent. We can confidently move on to the next part. This is just a matter of placing all the sprockets in the correct location with some M8 nuts, and locking those in place with some thread lock. The bottom sprockets are the ones with the bearings, so those just move freely. The top sprockets are connected to the threaded rod with the captured M8 nut from earlier, so those will rotate with the rod. That means they'll be actuated at the same time in perfect unison. I need a few more 3D printed parts, but I'm visiting family for the holidays and don't have access to a 3D printer. Luckily, there are companies with 3D printing services like PCBWay who supported this project. I just need to create a mesh first. Speaking of accessibility, I'll model these parts in FreeCAD, which is free and open source. You do not need expensive software or equipment to start building things like this. I'll just export this part as STL, upload it, select color and material, and that's it. PCBWay can do next level materials like aluminum and steel, or can CNC machine parts if that's a better fit. For now, I just need PLA plastic. I'll do the same thing to model a crank. So this kind of 3D modeling is called CAD, Computer Aided Design, and it's easier than it looks. If you're interested in designing your own parts, definitely give it a shot. There's plenty of great tutorials. Export and upload. While these parts ship, we can start adding the plaques. These are designed to press exactly into the internal geometry of the chain links. With all of those in place, this device is really coming together. Okay, so how the heck is this thing supposed to track who's up next for the printer? Each of these plaques has holes so we can affix acrylic to each one, and you can write on acrylic with a whiteboard marker. Whoever is up next for the print adds their name to the plaque. When a print is completed, the name is automatically erased and the device rotates to the next name. But in order to do that, this acrylic needs to be cut and given a white background so the marker is visible. I started with very precise cuts of paper, but realized I could cut basically any size and trim the edges with a sharp knife. And then I realized I could sand the acrylic with the paper already in place for a truly perfect finish. Here I'm just checking the acrylic doesn't catch anywhere during the rotation, and everything looks like it's running smoothly. The whiteboard marker displays clearly against the white background and erases cleanly. And the parts have arrived. I'll add the roof and the crank, and this device is almost finished. But I want 2 more things before I can call this complete. I want to frame the name of the person who is currently up, so that it is unambiguous. Also, I don't want to have to erase the marker by hand. I can solve both of these problems with this slider. It outlines the current plaque and has a space for material that slides along the acrylic to quickly and easily erase it. After some fussing about with correct positioning, I can secure this felt in place with some hot glue. The slider itself can be secured with some screws directly into the MDF housing. We can give that a quick test. And the erasing function is looking great. Now, you might be wondering why I picked 3 incoherent colors for this project, and the answer is I didn't. I actually picked 4. Did I say 4? I meant 5. This knob just had to be gold. Okay, I've set up the device by the 3D printer. Let's see the dramatic reenactment. Of course, it could always backfire. Luckily, I designed a workaround for such cases. The slot machine form factor gives this device other potential uses, like random number generation or life decision making. I'm very happy with how this turned out. It was a super unique design, and it was a lot of fun finding a creative solution in this one-of-a-kind way. This project is open source. In case you want to build it yourself, look for a repository link in the description. That's all for today's video. Thanks so much for watching. If you like this kind of content, be sure to subscribe, and I'll see you next time.